Hello and welcome back to our channel. In this session, we are going to discuss about Bernoulli's equation. Now, what is Bernoulli's equation? Before that, we need to know this is a topic under differential equation. Differential equation. Now, there are several topics under differential equation, but one specific topic contains this Bernoulli's equation. The topic is first order linear differential equation. Now, what is first order linear differential equation? Differential equation of the form dy dx plus px into y equal to qx, this one, and dx upon dy plus py into x equal to qy. Why first order linear? Because the unknown variable and its derivative are occurring in single term. Okay, that means y is present, no higher order of y is present, and only dy dx is present, no higher order of derivative of y is present. Okay. Similarly, in the second equation, second form, here x is the unknown variable, x is present in linear term, no higher order x is present, and dx dy, that means derivative of x with respect to y, that is also present in first order, okay, not in second or third order. So this is the type of equation that we say as first order linear differential equation. This is linear in y, this is linear in x. Now Bernoulli's equation is something that looks like dy upon dx plus px into y equal to qx into y to the power n. dy dx plus px into y equal to qx into y to the power n. Okay. Now, if n is 0, then y to the power 0 is 1, y to the power 0 disappears. So this is the replication of this quantity, this equation, dy dx plus px into y equal to qx. Okay. So basically this is linear in 1. But if n is non-zero, then what do we do? Remember one thing, if n is non-zero, then we can easily convert it into linear differential equation, first order linear differential equation, that means in either of this form. Today we are going to discuss about how to convert this into linear equation, linear differential equation, and then solve it. Clear? Let's begin. So this is the equation I am writing down here. Now, which term is creating the problem? The problem creating term is this one. Okay, this is the term that is creating the problem. So just divide the entire equation by y to the power n. So y to the power minus n into dy dx plus px into y to the power 1 minus n equal to qx. Right? The first step is divided by y to the power n. If there is no y to the power n, then this is linear in y, so divided by y to the power n. So this is the new form. Fine. Now look at this term, y to the power 1 by n. Assume it is t. assume it as t. So what is the derivative with respect to x? 1 minus n y to the power 1 minus n minus 1 dy dx equal to dt dx. Just differentiate both with respect to x. 1 minus n into y to the power 1 minus n minus 1, the formula x to the power n formula, n x to the power n minus 1, that formula I am applying. So this is nothing but y to the power minus n dy dx equal to 1 upon 1 minus n dt dx. 1 upon 1 minus n dt dx. Fine. So replace. This means 1 upon 1 minus n dt dx plus px into y to the power 1 minus n is t equal to px. So dt dx plus 1 minus n into px into t equal to 1 minus n into px. dt dx plus 1 minus n into px into t equal to 1 minus n into qx. Okay. Now what? Now look, only single linear term is present for the unknown variable and just first order derivative for the unknown variable. The rest of the term, this is a function of x, this is function of x. So this is nothing but linear in t, and now we can easily solve the problem. So up to this, if this is clear, I am not going to show how to solve the first order linear differential equation. That's not my point. My point is how to convert Bernoulli's equation to first order linear differential equation, and then we'll apply this and then solve a example. Okay, that we'll do. So this conversion, is it clear or not? What have we done? This y to the power n, we divided it. Okay, then we assume this y to the power 1 minus n as t, differentiated both sides, and replaced this part which is present y to the power minus n into dy dx, replace this part by dt dx, and then simplify. We got a differential equation which is linear in t. Now we proceed with the usual procedure. Okay. So if this is clear, let us solve a problem. Let us solve a problem on Bernoulli's equation. Now, there is a problem given dy dx plus xy equal to xy square. We have to solve this. Now look, unknown variable is y, because y is differentiated with respect to x, so unknown variable is y. We have to convert with respect to y only. Okay, we have to convert with respect to y only. That means we have to divide it by y square and convert it in linear differential equation. So if we divide it by y square, so y to the power minus 2 dy dx plus x into 1 upon y equal to x. Okay, divided by y square. Now this quantity which is present with px, assume it as t. So this is nothing but minus 1 by x square, extremely sorry, this is y, minus 1 by y square dy dx equal to dt dx, differentiation with respect to x. Okay, 1 by y equal to t, so minus 1 by y square dy dx equal to dt dx. Now what is this? This is 1 by y square dy dx. So this is nothing but minus of dt dx plus x into 1 by y means t equal to x. So this is dt dx minus x into t equal to minus x. This is linear differential equation in t. This is linear differential equation in t. Now we are going to finish the problem. So what do we do now? We have to calculate the integrating factor. That is e to the power integration tx dx. That means e to the power minus x dx, because this is what t is. So minus x dx. So the integrating factor is e to the power minus x square by 2. E to the power minus x square by 2. Now, so 1 gives us nothing but p into e to the power minus x square by 2 equal to integration over minus x into e to the power minus x square by 2 dx plus c. Just multiply both sides by integrating factor. The left hand side will become the exact equation. Differentiating the exact equation, left hand side we are getting this one, t into e to the power minus x square by 2, and the right hand side this minus x is multiplied with e to the power minus x square by 2, and we will be doing the differentiation. We will be doing the integration. Fine. Now this is simple. Assume x square by 2 as z. If we assume x square by 2 as z, so this is nothing but 2x by 2. So x equal to z times dz. X dx equal to x times dx equal to z dz. So this is nothing but minus of e to the power minus z dz plus c. Minus this x dx becomes dz now. X dx becomes z dz now. Sorry. Beg your pardon. X square by 2, this differentiation, x square by 2 equal to z, this differentiation on the left hand side, this is x dx, and the right hand side is only dz, because differentiation of z is 1 with respect to x, so this is dz. So x dx, this x dx will give us this dz, and e to the power, here there are minus x square by 2, so this becomes minus z. Now different integration of e to the power minus z is minus e to the power minus z, so this becomes e to the power minus z plus c, which is nothing but e to the power minus x square by 2 plus c. Okay, so t e to the power minus x square by 2 equal to e to the power minus x square by 2 plus c. Fine. Now we replace t and get the final result. So I am going to write this here. So what was t? T was nothing but 1 by y. This was our t. T was 1 by y. So 1 by y e to the power, so this, if this is 2, then 2 gives us 1 by y e to the power minus x square by 2 equal to e to the power minus x square by 2 plus c. Okay, so and last line, just multiply by e to the power x square by 2, so 1 by y equal to 1 plus c e to the power x square by 2. This is our final solution. Okay, so what we do in the entire problem? First, it is given in the Bernoulli's form, dy dx plus px into y equal to qx into y to the power n. Here n was 2. Okay. So what did you do? We divided by y square in the entire equation, both sides. Now we are getting y to the power minus 2 dy dx plus x into 1 by y equal to x. Now we replaced 1 by y by t, and accordingly we changed the entire equation. This entire equation after the change becomes linear in t, and now we apply the usual procedure. That means first we find out the integrating factor, then we multiply them both sides. In the left hand side this becomes an exact equation. Then on integration we are getting t to the power minus x square by 2, and then on the right side we perform the substitution method and we get the result. Then after the simplifying, after replacing the value of t, we get the solution, general solution of the differential equation. So that is how you are meant to solve this Bernoulli's equation. That means you have to convert it into linear equation, first order linear equation in the beginning. Okay, once you get there, the problem is very simple, the usual procedure. Okay, so if you like the video, if you like our effort, then please let us know. We'll be glad to help you out, and we'll keep you posting more videos like this. Thank you.